need to find x, so we're going to use the changing log to power format. So we know that x to the power 2, so the x is our base, this is our power, equals 49. Therefore we know that x is going to be the square root of 49, so x is 7. Similarly, 2 to the power x is equal to 8, and I know that 2 to the power 3 is 8, so x is 3. 25 to the power negative 1/2 equals x. Again, the 25 to the negative 1/2 equals x. To the power negative half, so that would be 1 over 25 to the half, and we know that to the power half is the same as the square root, so that's 1/5. Here we have two separate log statements on the left hand side, so we can join those together because they're adding. So log base 2 of x times x minus 7 equals 3. We then have a log statement as we have up above, so we can say that 2 to the power 3 equals x minus 7. Hopefully you notice at this point we have a quadratic. So 2 to the power 3 is 8. I'm going to expand this out. And we know to solve quadratics it has to equal 0. The quickest way to do this is by factorising. So I would know it's negative 8 because I have to multiply to give negative 8 and add to give negative 7. So it's negative 8 and plus 1. Solving this gives x equals positive 8 or negative 1. And we know we can't have log of a negative number, so therefore x equals 8. Question 4, very similar to that previous question. We've got two log statements on the left, so we've got log base 2 of x bracket x minus 2 equals 3. We've then got 2 to the power 3 equals 3, that should be a 3, equals x squared minus 2x. So 8 equals x squared minus 2x. 0 equals x squared minus 2x minus 8. Factorising this one gives me x minus 4, x plus 2, x equals 4 or negative 2, so x equals 4. I should stress that we must always discount any negative values, but in this question here it actually does say for x is greater than 2, so x equals 4 is the only solution we would have. Question 5 is a little bit different. So we have an expression on the left, 9 to the power x minus 1, and we have 1/3 to the power 2x. Now I know that 9 and 1/3 both are connected to the number 3. So what I'm actually going to do is, instead of writing the number 9, I'm going to write 3 squared. That's still to the power x minus 1. This 1/3 I'm actually going to write as 3 to the power negative 1. And that's still to the power 2x. Using rules of indices, we know that we would multiply our powers. So we've got 3 to the power of 2x minus 2 equals 3 to the power negative 2x. Here, because our base is the same, it means that we can equate our indices. So we would say that 2x minus 2 equals negative 2x. And we're going to solve this. So I'm going to bring my negative 2 to the left, so it becomes 2x plus 2x. And I'm going to bring my negative 2 to the right. So 4x equals 2, x equals 2 over 4, which is 1/2. Question 6. So log base 10 of this expression here. So we need to separate our terms in this part so we can have them as separate expressions for log base 10. First things first, I know that this whole expression here is squared. So I'm going to first of all rewrite this as log of p squared over q squared r to the power 6. So what I've done is I've squared all of my terms in that fraction. I now know that when I have a log of something divided by something else, I can have those expressions subtracted. So I can separate this into log base 10 of p squared, subtract, note my bracket here because I'm subtracting all of this denominator, log base 10 of q squared plus log base 10 of r to the power 6. I'm then going to deal with my powers. I know that the powers in front, when the power's here, it can come in front, so this can be written as 2 log base 10 of p. Oops, subtract 2 log base 10 q plus 6 log base 10 r. Then all we do is look up and substitute for x, y, and z. So this would be 2x minus 2y plus 6z.